This video looks at putting words into equations. It is the step before we do complete word problems to find our point of intersection, but it allows us to do let statements and our opening equations. So in this slide, we're going to practice writing algebraic expressions for the words below. The first example is about numbers. Let x represent the larger and y the smaller. Letter A is the sum of the two numbers. Sum means to add, so it's x plus y. Letter B, the smaller subtracted from the larger, so the smaller subtracted from the larger. Letter C, the larger subtracted from, the larger subtracted from 5 times the smaller. So 5 times the smaller. And letter D, the sum of 6 times the larger. Sum means to add, so 6 times the larger and 2 times the smaller. So 6 times the large and 2 times the smaller. So that is our example about numbers. The next example is flying speed. This type of example can also be applied to boats in the water and the speed of the current. So a plane flies x kilometers per hour in still air, and the wind speed is y kilometers per hour. So the plane is x and the wind is y. So if you're traveling into the wind in letter A, the wind is pushing against you. So in the air, it will slow the plane down. So you have the speed of the wind against the plane, so you are going to subtract it from the speed of the plane. Into the wind is the opposite, so you're going to add the speed of the wind to the speed of the plane so that the plane goes faster. The last example on this slide is the fitness center. A fitness center charges an initiation fee of X dollars plus a monthly fee of Y. So you've got initiation and then you've got monthly. So this is the initial, I'll use a short form, and then monthly. So the expression that would express 7 months would be the monthly fee plus 7 times the monthly fee. And for letter B, it's the same thing, only we change out the number 7 for the number 15. This is typical of things like plumbers, electricians, fitness centers, dining halls. There are many, many examples where there's an initial fee and then a fee for something else. Now on to our second slide with algebraic expressions for the words below. We have a swim meet where tickets to a college swim meet cost $10 for general admission. So $10 for general. And then we have $5 for students. So $5 for students. And you can see you can use other variables other than x and y to illustrate your expression. The total number of tickets sold would be the general plus the students. The revenue in dollars from the general admission tickets would be 10G. Notice I'm not using a dollar symbol there. The expression that we want is without any dollar signs or kilometers or any other indication of what the unit is. So just plain old 10G. The revenue in dollars from the students would be the 5S, and the total revenue would be 10G plus 5S. As we're going through this video, just a reminder that you can try to answer the questions ahead of me, so pause the video and then check to see if you get the right answer. My next example, we've got X dollars at 7% and Y dollars at 6%. The total amount of money Tracy invested, so just the money would be the X plus Y. and the interest Tracy earned at 7% in 1 year. The mistake I often see is 7x, but that would actually be 700%. So this one is actually wrong. So be careful here. What you're looking for is 7%, which is 0.07x. Remember that that represents 7 over 100, 7%. So the interest Tracy earned at 6% per year, very similar, 0.06y in this case. And the total interest Tracy earned in 1 year would be the two added together. So that total would be 0.07x plus 0.06y. On to the puppet play. And again, you can use different variables other than x and y. For the puppet play in the library, X tickets for adults and Y tickets for children were sold. The number of tickets was 256. Adult tickets were $5 and children tickets were $2. The total receipts were $767. So here, this is more an example of moving into equations, but simply the total number of tickets sold would be the X plus Y. And the total receipts were 5X, so $5 per adult, and $2 per children. However, with the information that we have, the total number of tickets was 256. So the equation that would represent that would be X plus Y equals 256. And the equation that would represent the total receipts along with its value would be 5x plus 2y equals 767. And now we have a system of equations, and we can solve. And we can figure out the number of adult tickets and the number of student tickets. We can also figure out how much money was made for each level. And now we move on to creating let statements and equations for each of the word problems on the slides. So looking at our first situation, we've got Pablo Picasso and Renoir. They produced a total of 295 paintings that have sold for $1 million each. Picasso accounted for 11 more of this total than Renoir. Typically, each sentence will contain an equation. You can define your variables first, or you can create your equations first. It's up to you and how your brain works. So going in order, I'm going to say let P represent or equal the number of Picasso paintings. It's important to define your variables carefully. And I'm going to let R, lowercase r, represent or equal the number of Renoir paintings. There are cases where you're going to want to use a capital letter for a variable. Typically, R that's capitalized represents total revenue. So in this case, I'm using lowercase r. In each sentence, there typically is an equation. So it says that Picasso and Renoir produced 295 paintings. So that will turn into P plus R equals 295. The second sentence says that Picasso accounted for 11 more than Renoir. So you have to be a little bit careful here. So Picasso accounted for. So Picasso equals, accounted for, 11 more than Renoir. So to balance that, to make them equal, you add 11 to the number of Renoir paintings. At this point, you can solve and you can find your two variables. But we're going to move on. I just want to practice at this point creating let statements and your opening equations. The next example is about measurement. It says the length of a rectangle is 6 centimeters greater than the width. The length and the width add to 46. So here, let L represent the length. Careful when you're using L as a variable. L's and 1s can look very, very similar. So I use a cursive L to represent length. And I'm going to say let W represent the width. Notice I'm putting centimeters in brackets just so you know what scale you're using here. So it says the length of a rectangle is 6 greater than the width. So the length is 6 greater than the width. So you have to add 6 to the width to have it balance out. The second sentence says the length and the width add to 46. So the length and the width add to 46. And there you go, 2 let statements and 2 equations. And again, once you have these 2 equations, you can solve to find what your length and the width are. Town areas. The area of Collingwood is twice the area of Dryden. The difference in the areas of the 2 towns is 17. So, once again, let C equal the area of Collingwood. And that's in kilometers squared. And let D represent or equal the area of Dryden. Also in kilometers squared. So the area of Collingwood is twice the area of Dryden. So to balance that out, the area of Collingwood is twice the area of Dryden. The difference in the areas of the 2 towns is 17. So when you subtract one from the other, the difference is 17. One more slide about let statements and equations. And now we have a gymnastic meet. Balcony seats for the gymnastic championships cost $10. And floor level seats cost $15. The total number of tickets sold was 331, and the total revenue was $39.15. So again, I'm going to use variables that make sense to me. So let B equal the number of balcony seats sold. And that's in dollars. And let F equal or represent the number of floor seats sold. And again, that's in dollars. So you can see that the total number of tickets sold was 331, and the total revenue from sales was $39.15. So going back to the blue highlight, the number of tickets sold was 331. So that would be B plus F equals 331. The total revenue was $39.15. So it is $10 for balcony seats plus $15 for floor level seats. Add those together for your $39.15. And now my last example, measurement. 2 angles are supplementary. The measure of one angle is 4 less than 3 times the measure of the other. Remember that supplementary angles are 2 angles that add up to 180 degrees. As an aside, complementary are two angles that add up to 90 degrees. So this is supplementary, this is complementary. So two angles are supplementary. The measure of one is 4 less than 3 times the measure of the other. I'm going to go back to let x represent the first angle. And that's in degrees. And let y represent or equal the second angle. And again, that's in degrees. So two angles are supplementary, so that means x plus y would equal 180. The second sentence compares the two. The measure of one is 4 less than 3 times the other. The measure of one is 4 less than 3 times the other. Let's just check that to make sure it makes sense. The measure of one is 4 less than 3 times the other. All right, that makes sense. And that concludes my video. Thank you for listening.